We are looking at tool set for problem solving, and specifically in this tool we are looking at viewing a problem from different perspective. Now if you look at the way this statement has been written, you can see that there is a difference between the first two tools, the fourth tool, and this particular tool. You know, the first two tools and the fourth tool are universal in nature, which means it can be applicable to all kinds of problems. Viewing the problem from different perspective, it may be able to help you in solving a problem, but it's not a universal approach. Just want to be make you cautious that it is often helpful to look at the problem from different perspective. It doesn't mean that it will always help you to solve the problem. It's not a catch-all, general catch-all. It's not a universal yeah, but still it's good to look at the problem from different perspectives. For example, if you look at this figure, the person to the left sees it as a 6, and the person to the right sees it as 9. Okay, they're having different viewpoints because they are looking at it from different position, different perspectives. Now the key point here is, in order for you to look at the problem from a totally different perspective, you have to change your viewpoint, which means you have to physically change the location from left to right so that your perspective changes from 6 to 9. The key here is to change the position from which you are looking at the problem. Okay, and when you look at the problem from different perspective, it may give you different views, insights. Yeah. So for example, in this figure, the person to the left sees it as 4 different rods, whereas the person to the right, who is looking at it from a different direction, from a different perspective, sees it only as 3. Okay. Now suppose you're a pirate. Suppose you're a pirate and you're on a lookout for a treasure. Now, your view to the treasure may be blocked. So, from where you are standing at the moment, your view to the treasure may be blocked by these mountains, by this forest, by this river. Yeah. So, from where you are standing, you may not be able to view the treasure at all. In order to have the insight in order to have the sight of your treasure, you have to change your position. You have to look at it from a different perspective. Changing the perspective means physically lifting and shifting yourself to a different point of view. Okay, once you're looking at it from this point, all those hurdles of mountains and jungle and river are not blocking your view, and you have a clear sight to your treasure. Okay, now this is what we'll be covering in some of the examples in this tool. Just to again make you cautious, it's very important that looking at the problem from different perspective may be useful. It is useful in many of the problems, but it's not a universal approach. Yeah, it may not actually lead you to solving a problem. Yeah, just look at this figure. Just because you're not able to solve the problem doesn't mean that by changing the perspective, by changing it, the physical location from which you're looking at the problem may help you to solve it. It may be able to solve it, but it's not necessary. It's not foolproof. In fact, some of the situations may be equally hopeless. So for example, you look at this person who is strangled on an island. Yeah, he's there for many days, and all of a sudden he on the horizon he sees a boat which is coming towards it, and he gets very excited. After so many days, he's finding someone who can potentially rescue him. Okay, but look at the same situation from the person who's on the boat. For the person who's on the boat, if you look at it from his perspective, this guy, this poor guy might have been on this boat for weeks together, without food, without water. Yeah, and he has been, just drifting across the ocean, and all of a sudden he finds a small island which gives him some hope. Yeah. Now, from either of the two perspective, it's a hopeless situation. Yeah, just that the both of them do not know. Yeah, both of them are not aware of it. Uh, Similarly, changing the perspective may not able to solve the problem, but in many cases it is quite helpful. It may be able to solve the problem. Let's take an example. Yeah. So for example, how many four-digit integers from 1000 to 9999? 1000 and 9999 are the smallest and the largest four-digit integers. How many of these four-digit integers have at least one digit repeated? At least one digit is repeated. So for example, in 1000, you see that 0 is repeated, not just twice, but it is repeated three times. In 9999, this 9 is repeated four times. So in the range from 1000 to 9999, you are supposed to find all those numbers. How many of them are there such that at least one digit is repeating? Yeah. So let's look at some random example, just to give you an insight to the problem. Let's look at 2572. If you look at 2572, it's a four-digit number. It is in the range 1000 to 99, and it has the repetition of digit 2. So which means we should be taking it off, which we should be taking it on, saying that this is a number which satisfies the condition that we have in the problem. Let's look at the next number, 2573. None of the digits are repeating, all of them are unique. Yeah, so it's not following, it's not of our interest. The next one is 2574. Again, no digit repeating. We come to 2575, the next one, and you notice that the 5 and 5 are repeating, which means this is of our interest. We should be counting it in. 2576, no repetition. 2577, we find a repeat of 7 and 7, which means we should be including it in our count. 2578, no repetition. 2579, again, there's no repetition. And then we go to 2680, which is again not having a repetition. So we have just look at some random sequence of numbers and see which one of them are of our interest and which one of them are not. Now, just by looking at this sequence, there's no pattern emerging. It's not a regular occurrence of after every third or every fourth take you'll be getting across. There's not a repeatable pattern. There's no repeatable pattern that you can derive from it. Which means it's not that we can look at this set and then extrapolate it to the entire range and say that yes, the total number of counts should be this. You can't use the extrapolation for it. So what will be the traditional approach in solving the problem, in this solving this problem? It will be to list down all the numbers that you have and then observe each one of them. Yeah, like we have listed here, and then observe each one of them, and then wherever you find a repeat, you will count it in. If you're not finding a repeat, you will be leaving it out. Yeah, so that's how we'll be that's the obvious approach to solving this problem. But then the challenge here is there are too many numbers here between 1000 to 9999. There are so many. There are 9000 numbers. You can't do this step by step for 9000 numbers. You can't list them down all, and it will take ages to follow this method. So there must be another way to solve this problem, and that's where the change in the perspective comes to your help. Yeah. So when you're trying to solve this problem, it's like you're looking at the treasure from a particular point of view, but then so the treasure is your objective. This is your starting point, but your view is blocked because there are too many hurdles inside. So if you change your perspective, yeah, from this point of view, you can't see the treasure at all. But if you change your perspective, which means you're physically looking at it from a different angle, from a different location, then you may be able to solve it. So let's see how it is applicable in this solution of this problem. Now our objective is to find all the numbers in the range 1000 to 9999 which have at least one digit repeated. Yeah, we are supposed to find all the numbers which are satisfying this condition. Let's represent this set of all the numbers which are satisfying the condition by a rectangular block. So this rectangular block is basically a set of all the numbers which are satisfying the condition. Now you have to be aware of the larger what you call range in which this set sits. Basically, if you look at it, this set of all the numbers which are satisfying the condition is part of a larger set. It's a part of it's a subset of a larger set which is essentially all possible numbers between 1000 to 9999 are represented by this large oval set. And how many such numbers are there between 1000 to 9999? There are 9000 such numbers. So this green oval represents the large set in which there are 9000 numbers, some of which are part of the numbers which are satisfying the condition. Now, if you take away this rectangle from this green oval, you are left with a cutout set. Yeah. So this yellow shape, which does not include there's a hole here. There's a hole which is cut out. This yellow shape represents all the numbers, yeah, which are not satisfying the conditions. All possible numbers, you have taken out all the numbers which are satisfying the condition, so you are left with the numbers which are not satisfying the condition. Now, the reason why we are doing it here is uh, it may be difficult to find the numbers in this set. As we saw, it's a very cumbersome what do you call cumbersome method to list them down, all of them, and then see whether they are following the conditions or not, and then count it. It may be much easier to find this particular set. We already know that this is 9000. It may be much easier to find the numbers which are not satisfying the condition. When we say not satisfying the conditions, it means numbers which are in the range 1000 to 99, part of the larger green set, but they do not have any digit repeating. None of the digits are repeating. Yeah. So let's look at the problem. Let's shift our focus. Instead of finding all the numbers which are satisfying the condition, let's look at it from a different perspective, and let's focus our attention in finding all the numbers which are not satisfying the condition. Yeah. And how will we do that? If we see, basically we are interested in all the 4-digit numbers in this range. Let's make a table. Yeah, the table, as we have learned in the universal approach to problem solving, it's always better to draw a table which is a much concise and a better representation of the information. So we are making a table in which we are listing down all the places. So the first place is the 1000 place. This column represents the 1000 place. Then we have the 100 place, which is the second position. Then we have the 10th place and the units place. Yeah. Now, for each of these, we'll try to find out what all possibilities are there, which all digits can fill into this place, in the 1000 place, and from which all digits that can fit into this place, you will find how many number of possibilities we have, how many number of different possibilities we have. And we'll fill this table, and we'll try to answer. We'll try to make up the count of this particular subset. Now, when you're looking at the 1000 place, you have got lots of options between 1000 to 1999, which means the 1000 place is ranging from 1 to 9. You've got 9 different options. Any of these digits 1 to 9 can fit into your 1000 place. Remember, you can't fit in a 0 here, because if you put a 0 here, then it doesn't become a 4-digit number. It becomes a 3-digit number, which is outside the range which is given to you. So when you're looking at the 1000 place, it can be any of the digits 1 to 9. And how many such possibilities are there? You can do it in 9 different ways, either 1 or 2 or 3 and so on up to 9. So there are 9 different possibilities. Once you have filled in your first place, which once you've filled in your 1000 place, then because your objective is to find a number which is not having any digit repeating, you out of these 9 possibilities that you have, one of the digit is already used up. We don't know which digit, but out of this 9, one is definitely ruled out when we come to the 100 place. You're left with only 8 out of these 9 numbers, eight out of these 9 digits which can fit into your 100 place, so as to not having any repetition. Now, in addition to 8 out of 9, you now also have the flexibility of using 0, because 0 could not be used in the 1000 place, but it can now be used in the 100 place. So the 100 place can be filled by any of the digits from 0 to 9, except the one which has been previously used in the 1000 digit. Yeah. So between 0 to 9, there are 10 different digits, out of which one digit has already been used up here. You've got 9 options. You've got 9 options here. One is taken off in the thousand place. So this can be filled in 9 different ways. Then we come to the 10th place. When we come to the 10th place, out of, we have already used up 2 of them. The first is used for the thousand place, the second is used for the hundred place. Now out of the 10 digits, you are left with only 8 options. So all the digits from 0 to 9 except the ones which are used in the thousand and the hundred place, that gives you 8 different possibilities. Yeah. Likewise, once you have filled in the 10th place, you are blacking out another possible digit. So you're left with 7 choices when you come to the fourth place. The fourth place can be any of the digits from 0 to 9 except for the 3 digits which have been used in thousandth, hundredth, and the 10th place. So which means it can be filled in 7 different ways. Now the key point to note here is all these places can be filled in independently. When I say independently, it means, for each of these 9 ways that you have used here, there can be 9 possible ways for filling in the hundred place, 8 possible ways of filling the 10th place, 7 possible way of filling the the units place. Which means if you have to look at it holistically, the number of numbers which are satisfying which are not satisfying the condition of repeatability are 9 into 9 into 8 into 7. So that's 9 into 9 into 8 into 7, which if you calculate is 4536. Now coming back to our the previous slide, when we talked about the sets and subsets, we are supposed to find the numbers which are satisfying the condition, which were identified by this rectangular block. We know that the superset is all possible numbers between 1000 to 9999, which is 9000. And then we changed our perspective to find all the numbers which are not satisfying the conditions, which were 4536. Yeah. So our objective is obtained by subtracting the numbers which are not satisfying the condition from all possible numbers. So from 9000, if you subtract 4536, you'll be left with 4464, which is the number of numbers in this range which are satisfying the condition. Yeah. Now notice in this case you are lucky enough to change the perspective and solve the problem. But just to re-emphasize, just changing the perspective may or may not help you. It's always better to have it as a toolkit, but be aware that sometimes it may work, sometimes it may be equally hopeless.